thank our partners, Droid on Roids, which is mobile and web development company, great software house with very well experienced Flutter developers, which is also highly involved in the community. So GDG Wrocław is cooperating with them for quite a long time. And also, I would like to thank Merixstudio, software house, in which office we are currently now. They're also highly involved in the community. So just if you're interested, just take a look at their offer, and we'll on their webpage, so we can actually start. Okay. Okay. So we would like to start with presenting our agenda. So we'll start with Pedro Belford, who will talk about Freeze package, which will help bringing your code to much better level. The second presentation will be by Dominik Roszkowski, who will talk about animations. And the third and last one will be by Krzysztof Sroka, who will talk about debugging Flutter code. So I would like to invite Pedro Belford on the stage, so we can have just one chat with him. Pedro, are you here?
Hello, can you hear me?
Hi, Pedro, I can hear you. How are you today?
I'm fine. Thank you for having me here.
Thank you for having us. So can you tell us slightly more about your presentation? What are your expectations?
Yeah, sure. So we're just gonna have a very casual talk about Freeze, which is a Dart package that is surely gonna help level up your code safety. And it's something that can be a very good addition to any project, especially bigger projects, because it's gonna enforce certain conventions that you wouldn't have it otherwise.
Great. And maybe you can also introduce yourself. Tell us something about you. How did you actually start working with Flutter? What was the first moment?
Yeah, so I started working with Flutter more or less a year ago, and I have actually 5 years of experience with native mobile development, Android and iOS. And I decided to dive into Flutter because, well, I think that building two code bases can be very cumbersome, and we should make better use of our time. And honestly, I just think that Flutter gives you an overall better development experience. So I just fell in love with it.
Great. Also, like, if you can just briefly introduce us with your career path, like what are your most interests?
Yeah, so I am very into mobile development, so I'm pretty, I guess I am in the right place. And I am also very involved with e-commerce. So right now I work for a unicorn company based in Hamburg, Germany, called About You. And our app is built completely in Flutter. So make sure also to check out. The name is About You. It's a fashion tech company. And I'm also the co-founder and engineer at Lutic, which we are also a software house, and we build mobile apps from scratch. And I'm gonna make sure to provide you with a QR code so you can check out our website later.
Okay, great. And also, what are your opinions and what are your feelings after Flutter Engage event and introduction of Flutter 2.0?
You know, I think that Flutter 2.0 is very exciting because it's gonna embrace a range of other domains and I think other platforms as well. And I think that's very exciting because you're gonna invest your time in learning a framework and mastering it, and you're soon gonna be able to make very high quality applications, not only for mobile, but also for, who knows, web, and of course, desktop and the other platforms. So I think that's pretty exciting for everyone.
Great. And what are your feelings about this Flutter for web? Did you actually wait for it like most of the community, or?
Yeah, I was waiting for it. I'm not sure if we're quite there yet. Maybe I wouldn't use it in any form, in any applications, to be honest. But I'm very excited and hopeful that it evolves in the right direction.
Yeah, that's true. And also the thing about, you know, adding all those different platforms, like especially the cooperation with Ubuntu, that was also quite exciting, I guess. Did you actually also try it yourself or not yet?
Yeah, but I think I just scratched the surface. I think that there's a lot more to explore. Like they released a bunch of demos that are definitely worth it to give it a try.
Okay, great. So I guess that we are almost on time to start your talk. So I guess we can start with showing the screen, and we'll start.
Sure.
Good luck.
Hello, welcome everyone to our first talk. Today we're going to talk about Freezed, a Dart library package that is going to surely help you level up your code safety. But before we actually get started, let me introduce myself. My name is Pedro Belford. As I said a couple of minutes ago, I am originally from Brazil. I have 5 years of experience with native mobile development. More recently, I got into Flutter, which for me is game changer because it gives you the best mobile development experience so far in the market nowadays. I'm also a senior Flutter engineer at About You. This is a fashion tech unicorn company based in Hamburg, Germany. And make sure to check out our app. It's amazing. So if you're looking for new clothes or just a gift to our friends, we might have whatever you need. So it's available for both Android and iOS, and it has been written completely in Flutter. I'm also the co-founder and engineer at Lutic. We are a software house specialized in mobile applications. So whether if you are you need an extra pair of hands for a new project, or if you are building a new app from scratch, we might be able to help. So make sure to check out our website. This is the QR code for it. All right, so let's get started. As most things in Flutter, you probably got started like this: Flutter create. But instead of calling my new app, my new fictitious app, my awesome app, let's just give it a nicer name. Let's call it Iceberg. Well, Iceberg is a fictitious e-commerce app. As many e-commerce apps, you're gonna have to deal with a bunch of features. So we have our product catalog, we have our cart, loyalty program, and many other features that you're gonna have to develop until you actually deploy it into production. Now, just to give you some context, let's say that this is the architecture that I decided to use for my application. We have a presentation layer, we have a business logic, data access, and data source, and we are using the block pattern for state management. Now, Flutter is amazing because it provides you with a bunch of features, which enables you to build a very complex UIs in a very, very straightforward way. So I would say that most of the problems actually arise when you're actually dealing with state management. And more than that, well, today it's you. 1 month from now, maybe there are 2 people on your team. 3 months from now, there are 2 people plus 2 others that you barely know and might be doing crazy things. And 12 months from now, you might be all over the place with a remote team, with different mindsets, different cultures, etc. So things can get pretty messy. What can possibly go wrong with that, right? Well, I'll tell you 4 things that might go wrong with that. So first, you might pass around data, which might change unexpectedly. Second, you might forget to cover some state in your widget. You might spend too much time with boilerplate code. Or you might just write code that is difficult to read and maintain. Whenever. Okay, so when we talk about passing around data which might change unexpectedly, well, this is probably ring a bell to many people. How do we tackle this? We are looking into immutability. And thankfully, Dart actually provides us with a very nice set of tools and keywords to actually tackle this problem. So of course, let's start with something very simple here, just for simplicity's sake, right? So let's say that I have a user object with the first name and the last name. Now, obviously, this class on the left is not immutable yet. but we're going to do it. So this means that I can just go ahead, I can declare my user, which is a white walker, and I can change its name to Moon if I want to. Now, how would I tackle it in Dart? I can just use the final keyword in front of my type string. And now the compiler will tell me that it cannot be used as a setter because it's final. If I go one step ahead, I can also make this user constant. And if I actually declare another user who is constant and has the same first name and last name, I get value equality. If I go further, I can also annotate it with the immutable decorator. Now, what this is going to do is, basically, it's going to tell your developer that, well, if you are actually including a new property that is not final, it's not supposed to be like that. So one or more of these instance fields aren't final, in this case, user address. But be aware, this is not enforcing anything. It's just giving a warning. If you go one step further, you're probably going to add some required decorators and also some assertions to make sure that neither the first name, last name, or address can be null. All right, so in the end, I cannot change the first name, I cannot change the last name, or the address. All right, so when we talk about forget to cover some state, minutes ago, we just talked about how many features probably an e-commerce application is gonna have. Product, cart, categories, rewards, etc. Can you imagine how many states we're gonna have to manage here? It can be very, very cumbersome, and it can be very confusing very fast. So wouldn't it be nice in the product catalog, for instance, if we could, let's say, if we had, for instance, this triad, there you go. If we had these three states here, which is a very common case for any page. We have the loading, we have the success, and we have the failure states for the product catalog, right? Now, how would we write this with vanilla Dart and using, let's say, the block, the Flutter block package? Well, we probably have something more or less between these lines, right? So we would have an abstract class calling, I'm going to call it product catalog state, and you would have three other classes that would extend from this base class, right? And they would represent the possible three states of your page. I have marked them also with some colored circles on the left just to make it easier to visualize what I'm trying to say here, okay? So this is how it would look like in Dart. And of course, you would have to cover these in your widget. So let's say that I have, for instance, a content widget, and inside it I have my build method, of course, and I have a builder. And inside this builder, I have to address each state. So in this case, if my product catalog is loading, I have to show a circular progress indicator. If my product catalog has loaded successfully, well, I have to render my product stream. Now, if I have a failure in this load process, then I have to show a failure placeholder, right? Pretty intuitive. What's the problem with this so far? Just one tiny annoying thing. Here, actually, the compiler is gonna complain and give you a warning saying that you have to return something. It doesn't recognize that, in this case, you have covered every state. This can be pretty annoying, but you can solve it very easily with, for instance, a size box, and that's it. Because you know that the fallback state is never gonna happen because you have covered every state before it, right? So what about if we went back to this class and we added two new states? Let's say that the PM told you, okay, now we need the empty and we need the initial states. Now, this was your widget, and these were the states that you had. So if you go to your block and you add those new states, you have to make sure you remember and come back here and address every new possible state. You have to remember this. Your teammate has to remember this, right? And well, if you have only 2 new states, that might be very trivial. But imagine if you have a much more complex feature or UI to build. And what if your fallback was actually the failure placeholder, and you forget to come back here and update your widget? Then all the new states would fall into this new category of failure placeholder. And that wouldn't be pretty, would it? So in theory, wouldn't it be nice if we could have a switch saying, okay, for this state, I have this possibility. So I have the loading progress, load success, and load failure. And the compiler actually tells you that you have covered every state and understands it, right? So if you modify anything, all right, you come back here and you cover the new states. And if you have covered everything, that's all right. Like you did your job, right? So it would be very nice if we have, oops, you forgot to cover the new initial and empty states in this case. Our next problem is that you might spend too much time with boilerplate code. And it would be so nice if you had some of these code that you expect auto-generated for you. It could be through, let's say, code generation. Why not? Okay, so let's say here that I am in my block and I have my famous map event to state function. And in this case, this is a very, very isolated example. Let's say that I want to update a user profile, and I am concerned in giving the fastest feedback possible to the user. So I want to do everything local. I'm not loading anything. Okay. So I have this user profile. I already have this object, right? And I just want to update one single property of this object. Well, with Vanilla Dart, what you would have to do is, well, one of the things you could do actually is instantiate a new user profile, and you can pass in all the properties again and change only one of them, the one that you're interested in, okay? But what we usually see in Flutter is the copy with method. And this method is pretty cool because it allows you to just go to your object and say, okay, dot copy with, and then pass in the new value of the property that you're interested in, right? But this method is not created automatically for you, which means that if you are in a new class, you also have to remember to create this method, for each class that you're interested in. And also, let's say, if you have to maintain the class and update it and include a new property, you have to go back, remember that you have to add a new property, a new argument to the copy with method. And let's not forget that this method, the way it's written, it does not support null values. So what if you want to set something for null, as null? Okay, I talked about copy with, but what about all those assertions that we've seen minutes ago? What about the quality operator? What about the hash code? What about toString? There's so many things that you would have to override, and they are like, you're gonna do the same process over and over again. Wouldn't it be nice if you just had everything you needed out of the box? Okay, hold on. Our fourth issue. So this is very abstract, I know, but basically we are looking into predictability. So it doesn't matter if I'm writing the product catalog, the card, or the customer service. In the end, you want to have some degree of familiarity in each feature that you visit. You want to know more or less how you're going to build these things. What are the conventions? How you must proceed? Where you have to look at in order to figure out how a new state is created, how a business logic is done, right? So you want to have some degree of familiarity in each feature that you visit and you are about to build. So wouldn't it be nice if you actually had the answers for how is the state updated? Which are the possible states for my page? What are the assumptions I can make for immutable objects? What are the tools I have to work with? So this is something that you not always have the answer. And it would be great for your workflow and for your team if you actually manage somehow to enforce these answers in a very consistent way. Well, say hello to Freezed. This package is amazing. But before I actually talk about the package itself, I want to talk about its creator. This is Remy, and you might know him for other packages. He did an amazing job in the Flutter community. So he's also the author from Provider, RiverPod, Flutter Hooks, and Freezed, of course. So what do you get with that? Well, Freezed gives you a bunch of convenience for your development workflow. So out of the box, what do you get with it? You get immutability by default. You get union and sealed classes. You get exhaustive switch, automatic value equality, copy with supporting new values, automatic toString override, property destructuring, early access to the late keyword, non-null by default, and a very neat integration with JSON serializable if you're handling JSON, which most of you are probably. And let's not forget, it gives you a very elegant syntax that speeds up your workflow. And I'm gonna show you a little bit of it. Well, if you want to integrate your project with Freeze, you have to insert these dependencies. So basically, Freeze annotation and the build running, of course, because this is a code generation based package, and Freeze. And these versions here, I put them here if you are not able to migrate to Flutter 2.0 yet, okay? So you would use these versions. Okay, so let's get back to Iceberg. And let's say that I'm gonna build my first and maybe one of the most important features, the product catalog. And what better way to start it than my model, product. As we've seen, this would be the way, like very simple way of writing the product object in pure Dart, okay? So again, I have my ID, name, and price. They're all final. They all have the required annotation. And I also included the immutable decorator on the top to make sure that this object does never have a state. All right, so this is how it would look like after Freeze, if you had to refactor this to Freeze. Take a moment to look at it. But don't worry, I'm gonna go step by step here and show you what changed. The first thing that you might have noticed is that all the properties are not declared anymore within the class, right? So you're just declaring a factory constructor, right? Your class became an abstract class, but be aware, the abstract keyword is not needed anymore in the modern versions of Freeze. You're also putting a mix-in product that is auto-generated for you. As I said, now it's a factory constructor. And you have a private implementation of the product class. Of course, you have to annotate it with the Freeze decorator. So the code generation tool knows that it has to generate code for this specific class. And you have to import Freeze annotation, of course, and write this part product freeze.art. Okay, if you do all this and then, of course, you run your build runner, this is going to generate code for you. But just a pro tip before we do it, also consider importing foundation, because if you do so, it will give you some convenience debugging properties that is going to make your class look much better in Flutter's dev tool. So definitely worth it. As I said, Flutter pub run build runner build. After you reach this command, it's going to generate for you a lot of code. But don't worry, you don't have to read this. I just want to show you how much code is being auto-generated for you, okay? Now, I want to highlight a couple of nice parts that are within this code. It generates for you an identity. It also generates for you a product tear off. This is the copy width that we talked about. And this is what you get when you import foundation. And of course, the private implementation of the product class. Now, let's zoom in here. Okay, so this is our private product class. As you can see, we have the same factory constructor, but now we have the properties. And more interestingly, here we have getters, which make these fields immutable. You cannot set them from outside. And you also get the copy with method we talked about. Now, what about this other implementation of product? What do you get with that? Well, first, you also get the mixin that I mentioned for when you import foundation, and you get the toString override. Gives you a very nice view of the class and its properties. You also get equality operator override and hash code. And these are the debuggable properties. In other words, by writing this, you get this. Non-null by default. You don't need to write those assertions anymore. It's non-null by default. This is especially useful if you cannot migrate to Flutter 2.0 yet. You get immutability by default. So just by writing this, no one can change ID, name, nor price. Automatic toString override. Automatic value equality, which is very handy if you're dealing with states. You also get, for you, the copy with method. Let's say that I have a drone product and I just want to update its price. Well, that's super easy. I just have to say drone, copy with, price, and the new price. There you go. And of course, the previous object is not equal to the new one because the price has changed. Now, let's say that I said that it also supports new values. So we have to modify a little bit our class on the left. Let's say that now I have an image URL, which is a string, but it can be null. And as you can see, I have already declared my drone without an image URL. So it supports null values. And I could pass here in the image URL a null if I want, or I could pass an image. But here is where it truly shines. Remember our states for the product catalog. We had the failure, loading failure, and success states. Previously in Dart, you write it this way. Now, with freezed, this would become this. Well, say hello to union and sealed classes. Look how much better it reads. You have your loading, success, and failure all nested within your product catalog states. Now you have factory constructors to declare them. And freeze is actually implementing the states, which now can be private. And one of the biggest advantages that we get from that is what we're about to see. Remember how we had to declare our states in our widget inside our builder. So we have the loading progress, load success, and load failure, and you have to typecast that, right? Now, you get an exhaustive switch with the when method. So you would say, okay, state, I would like to return when my state is loading, I'm going to return a circular progress indicator. If it's success, then I'm going to return a product stream, failure placeholder. Another thing that you might notice is that we also get property destructuring. And this is why you don't really need your state to be public anymore, because you have all the properties you need destructured for you. So in the success, I don't need to verify if it's a product catalog success state, for instance. You can just say, okay, my products, I want to render a product string with these products. All right, and what about new states? Let's say that I have empty and initial. This is how you would modify your product catalog state, just new factory constructors. And you would get compile time error and warning saying, okay, the parameter empty is required. The parameter initial is required. And you would have to go back to a widget and include those states in your when method. So you do have exhaustive switch compile time. And you know, all these features, they were heavily inspired in Kotlin. Most you probably know, but Kotlin has support to data classes, which allows us to declare, for instance, name and age, and the compiler automatically derives the following members from all properties declared in the primary constructor. So you get the equals similar to what freeze does. So you get the equals, you get the toString, you get the copy function and component end out of the box. Kotlin also supports seal classes. So you would have, let's say, 3 classes here that extend from expression. And the nice thing about this is that all the subclasses or seal classes are known at compile time, just as freeze gives us for Dart. Guys, in summary, so for the first problem we talked about, you get immutability by default with freeze. So you never forget to cover any case, because you get union, with union and seal classes, you get the exhaustive switch. You never have to spend too much time with boilerplate code anymore, because you get automatic toString override, you get the copy with methods, and you get property structuring for you. And your code is going to be much more predictable because you have automatic value equality, and the properties are non-null by default. So you don't have to rely on conventions anymore. If you're using freeze, you can be assured that you're going to have this set of behavior for sure. Well, we talked about most of these features that freeze offers us, right? But those are not exhaustive, okay? So we didn't even mention the early access to the late keyword or the amazing integration that it has with JSON serializable. Not only that, there's just so much more. So you also get custom getters and methods. You get deep copy, constructor tear off, other decorators. For instance, you can put deprecated. You can also make assertions, and you can also break the rules and say that a required property is actually nullable. You get mixed scenes in your faces, and part of other powerful methods like maybe when and map and maybe map, which allows you to actually use your states, which now can't be private, but you can actually make use of the state object itself. So make sure to check it out, because there's a lot more to cover. And of course, as anything in life, there are trade-offs. But this is more of my personal opinion, to be honest. One of the things I don't like about it is the fact that your assertions now, they are based on string literals. So this is how you would write that name cannot be empty with freeze. And this is very prone to error, but as when you generate the code, you're gonna figure it out. So this should not be a huge problem or a no-go for you. Another issue that I see with freeze is that you have frequent code generation, and that can be very bulky, because it's another thing that you have to do in your workflow. You're always generating code all the time, and especially if your code base is big, it can take up a long time. So this can be easily tackled as well. Like you can just declare a new file, build YAML, for instance, and there you can optimize which code is going to be scanned, and is going to be the base for generating freeze classes. You can come up with a suffix, for instance. This is something that we ran into in About You. And in the end, like, it's just something that we had to optimize, and we managed to reduce the build time and the code generation time, and keep all the good things that come with Freezed. So it's just one more thing that you have to consider, of course. And of course, it's one more thing for project newcomers. So anyone who is onboarding your team, you're gonna have to teach them how to freeze, how is your new workflow. But again, this is something that you probably have to do with a bunch of other technologies as well. If you're using something like RX Dart, it's a different way of programming, and well, many other packages that are out there. So this is just something that you might keep in mind. But again, this is just the tip of the iceberg. Now, if you have any questions, it's the time for it.
Okay, thank you, Pedro, for your great presentation. I'm here to read the questions. But also, first of all, thanks for the talk. It was very nice quality, and I feel that you actually really covered it well. So yeah, let's see if we have any questions on our channels. Is there anyone? Okay, we have first question from Dominik Roszkowski. Pedro, how do you cope with very long build runner times when it comes to Freeze? In relatively big app that's been in dev for 12 months, it takes over 2 minutes to generate everything. I hope you actually answered the question also.
Yeah, we've been through that in About You. Yeah, it can be especially challenging if you're using other packages that use code generation as well. Basically, what we've done is we created a build.yaml file, and we configured how we want to generate code for Freezed. And well, in the end, it was quite simple, the solution, but quite effective. What we did is we refactored each of the files name, and we added a suffix with CG, and we set in the build.yaml that we only want Freezed to look at those files, and that speed up the process like exponentially. So before that, we were taking around 7 minutes to generate all the freeze classes, and after that, it took 30 seconds. Honestly, it's not an understatement. And it just completely changed our lives. This is when I actually start loving Freezed as well. Just after that, because before that it was more of a I don't know, it was more of a stone in your way. But after that, things just got super smooth. A big shout out to Marco, who's the guy that figured out how to do it, by the way.
Okay, so after this, you actually were able to unfreeze your code. Okay,
yes.
Do you have any other questions? Okay, so I have one question from my side, because you've actually introduced Freeze in a very nice way, so we actually see how powerful this tool is and how important it is to use it. And also, as you've said, there is pretty much not a lot of problems if you properly introduce it also and cope with this code generation, frequent code generations. But my question is, as far as you've said, you were introducing it in About You. So what was your route? Like any maybe tips, maybe some ideas of how to do it efficiently, maybe what to prevent?
You mean how to introduce Freeze to your project?
Yeah, exactly. Like I'm talking about already existing application, and you're just deciding to introduce Freeze to it.
Yeah, it's always challenging, right? When you already have a nice architecture and you decide to introduce some code generation library like Freeze. So basically what we've done is since the beginning, we decided that we wouldn't go like radically and just, refactor every class that we have and everything must be Freeze. No. We actually said that we'd only explore it in new features and if that actually made sense, right? Because sometimes you just have a simple state and a simple object and you don't need it to be strictly immutable, right? So what maybe my advice would be to balance and weigh the pros and cons for the features that you're building, and if you truly need it, and to do it incrementally. Like if you're building a new feature and it's going to be complex, you really need to immutability right there. Consider using Freezed, and it's going to be like piece of cake, you're gonna love it, etc. And then you can come up with like a ticket and maybe negotiate with your product manager so you can tackle this tech debt and refactor other classes with Freezed. We did that, for instance, for our email and login sign up, and that worked pretty well.
Okay, and what was the impact on the code base? Like the last question, did you actually measure the impact on the amount of lines of code that you were actually rid because of introducing Freeze to your application?
Not really. We didn't measure how many lines of code we saved, but I can say that I think that the biggest advantage of using Freeze is that you go with much more confidence in classes and features that have been built with Freeze, because you have a very predictable behavior, and you know that your state is not gonna change like in a very weird way along the everything that is going on in your block or in your widget. So it's much more. And I think it's also speeds up the development process because you're just much more confident with what you're touching. You know that nothing's gonna change out of the blue.
Okay, I see that we have like one more question from the audience. It's a question from Okay. Any tips for refactoring app and add freeze? Yeah, so pretty much.
App and add freeze. Well, I think this is really similar to the last one. Basically, my tip would be don't go with the mindset that you have to change everything. Do it incrementally. Test some new features. See if you like it, if it's really bringing. Because at the end of the day, what you want to do is build high quality application and work well with your peers, right? So it's very important to get the support and see if everyone's working well with that. So test it, do it incrementally, and then create those tech debts and go back and refactor a couple of other features that you previously had without Freeze. And also I would go for features that have less states, because it just makes it easier, because it's easier also like to compare, before and after Freeze. And then after that, you're going to be much more proficient with Freeze, with all the new nomenclature, the new syntax, etc. And then you can go for the darker parts.
Okay, great. Thank you very much. I don't see that we have any more questions. So once more, thank you very much for a great talk. And
I would like to also thank a couple of people here. I'd like to give a special thanks to Marco Papula and Rafał, of course, Remy, and all the Freeze contributors, all the assets also from FreePick. Please, guys, make sure that you check out Freeze. Here's the QR code for that. You have about 5, 4, 3, 2, 1 seconds. And Lutic, please make sure to check out our website.
Okay. Thank you very much, then.
All right. Bye-bye. Thank you.
Bye. Okay, and for the rest of us, we have a break right now. So the next presentation starts at 6 p.m. That will be the presentation of Dominik Roszkowski talking about animations. So make sure you'll be there. We'll, of course, start with 5 minutes before with some sort of simple chit-chat, but that's probably the most important thing will be at 6 p.m. So thank you very much, and see you later. Okay, welcome back after our short break. Right now we will have Dominik Roszkowski talking about animations and Flutter. So please welcome him on the stage.
Hi everybody.
Hi Dominik, how are you
It's a
today?
pleasure to be here. Hi Rafa, it's good. Thanks a lot. How about you?
Yeah, I'm fine as well. I have to say that since you've become GDE, you have much better lighting, much better setup. It looks very professional.
Yeah. So I purchased the lights, especially for this kind of like late evening talks. In the winter, it was necessary. Now I hope that with longer days in the summertime, it won't be as necessary as it was before. But actually, it's like not so bright, but it still like makes me a bit blind because of that. So I'm not trying to look into the left. So
Yeah, like that's the cost
hopefully
of being
everything.
famous, you have to take it.
Yeah, I will send you my autograph later, so don't worry.
Oh, I hope that. I hope that. Actually, that's a good idea. Next time we can actually say that will be some, for our Kahoot quiz that we have at the end. That might be the case. That will be, the prize, the top prize.
But you have to also sign it. So if that's the prize, then we have to both sign it.
Yeah, but
And
then
actually,
with your autograph, the price of this Dashata will be quite high. Then we'll actually make it average. So I don't know if this is a good case, but try. Okay, before we start, I have one question for you. Because hence this is the meeting about Flutter Engage. So can you give us your opinions about Flutter 2.0, how hyped you are?
yeah, so I'm pretty pumped, especially about Flutter for desktop. So as you remember, actually over a year ago, I made a presentation about Flutter for desktop. And since then, like it all, like there was kind of a revolution in how stable the Flutter desktop right now is. So actually, even during this presentation, I'm going to use Flutter desktop because this is one of the easiest way right now, I think, to actually use Flutter. It's much easier to run Flutter desktop application right now when it's in stable, just behind a feature toggle. But actually, it's usable on stable, and it just takes a few seconds to build application, whether it's for Windows or Mac OS, and gives much easier start than actually having Android phone or iOS phone and going into the debug settings and so that all that stuff. And I hope that mostly due to this stable release of Flutter desktop, this will get much more popular. So we'll see much more, even like some basic Flutter apps, some utility tools, maybe some helpers, maybe even some Pomodoro trackers or whatever, because this is so easy right now, and it's much easier than it used to be 1 year ago.
Yeah, definitely, that's a huge step forward. So, yeah, but we are almost. It's almost time for your presentation. So I guess we can start with the intro. And good luck.
Thanks a lot, and see you after the intro.
See you. Bye.
Hi there, everybody. My name is Dominik Roszkowski, and today we're going to talk about animations and some ways to improve your skills when using them. And I hope that this talk will give you some kind of inspiration and some maybe tools to help you make your animations nicer, develop them faster. So this is not like a tutorial presentation. There won't be like a lot of live coding, but I'm going to show you some code. But in general, what I want to convey is some kind of different approaches to how you can actually use animations in Flutter. And because the spectrum of possibilities that you have in Flutter is pretty wide, so you all know about some basic implicit, explicit animations, maybe animation controllers. So I assume that this kind of knowledge or some basic understanding what kind of animations can you do in Flutter is already something that you know. However, I will go also into some basics just to give you some grounds to understand what we are going to talk about. But in general, my idea is to inspire you, to show you what kind of different approaches can you use in your Flutter apps. So let's start. No, maybe let me just also tell that I'm working right now at VGV, Very Good Ventures, and we are actually looking for some people to join us. So if you know Flutter even only a little bit, please check out our website for more information. So as I said, goals for today is to have an overview of animation approaches. I'm going to show you some tips and tricks, some code, how to actually maybe organize your animations in some more maintainable way, and give you some sources for inspiration, maybe some examples. Let's start with the basic stuff that's always when you have animation presentation is a distinction between implicit and explicit animations. So let's start actually with an example. So implicit animations are the ones that happen in some kind of response to your action and where you don't actually have to create any animation controller. They just occur between changes of some state, changes of some property. And actually, we say that implicit animation means that some property of a given object, it can be like its opacity, it can be its layout, it can be its position, or any other actually property is changed from one to the other. And Flutter and its internal logic will take care of interpolating the value between one and the other. So in Flutter, we have a bunch of different built-in implicitly animated widgets. So in this short list, you can see animated opacity, container, crossfade, switcher, physical model. And let me actually show you a short example. So I also prepared a small desktop application in Flutter so that we can experiment a bit with all of these animations that we're going to talk about. So here's my app. We're at the stage of implicit animations, and let's maybe just check out this animated align widget. So when I click at the button, the only thing that is actually changing is some random alignment applied to this text button. So if I click, it changes to some random value. And as you can see, the transition between position or the alignment of this widget is being interpolated automatically. So I don't have to actually do any sort of calculations or interpolation on my own. This is done purely via Flutter and its ability to interpolate two values from one to the other. Also, there is very convenient widget, and it allows to actually interpolate much more properties than just position, which is animated container. And when I click animated container here, some properties change, and I'm going to show you in a minute. But as you can see, many different things can change implicitly when I click the button. The same happens here. This is actually animated physical model, and animated physical model is something that is like a base for all the material widgets. So it means that it just has an elevation. Thus, this is physical because this has elevation and it casts a shadow. So when I click this, some properties change, and this makes them interpolate between. So let's just quickly take a look at the code that is that was used to make these animations. And what I do here is that, for instance, in case of this button, I just change between 120, 170, and 500 size. And maybe the radius is also changing 0, 16, 190. Yes, 0, 16, 190. The same for elevations and colors and so on. But the most important part is a bit lower. So for instance, here is my animated container. And I just apply some sizes, and I apply some color and some more stuff just in order to have a very convenient way to animate some properties. And this is something that may be used by you very commonly in your Flutter apps. And actually, just from some implicitly animated widgets, you can create very complex animations. However, so for instance, here we have animated align example, and the only thing that is changing is this alignment here, right? Sorry, I didn't mean to click it. The only thing that changes is alignment. And for instance, this is how it looks like for a different widget, in this case, Flutter logo. Here I have my unpressed, some random numbers are being apply to the alignment. And that's all that we have to actually do. However, sometimes the built-in implicitly animated widgets are not enough. And there is very handy base widget that we can use, which is called implicitly animated widget. And actually, all the other implicitly animated widgets are using this. But sometimes when you, for instance, want to animate something different than just some basic container property or basic position, you can use this base widget to create your own implicitly animated widget. And this is very helpful thing to do. And on this slide, you actually can see the full source code of this widget that you see on the right side. So in this case, what happens is, for instance, when you have like an upload indicator or download indicator, and you, for instance, get some data which is discrete, so you get like 01, 02, 03, 04, and none of the values in between, and maybe you want to make this animation a bit smoother, so we can use the implicitly animated widget to make it appear like fluid, make it more fluid, make it appear more smooth. So what you just need to do is to implement or extend the implicitly animated widget. And actually, what happens is that it has its own state. So you have to also create a state for this widget. And in your build method, you can use use a tween that is being created in a method for each tween. So you have to implement the method for each tween. And in this method, you have the another method, which is a visitor, that you have to use in order to create your interpolated value. And in my case, what I do is that I just create a tween of double, and we're going to go into the tweens in next slides. But what important is right now is that you have to create your tween, and you just need to provide this value as a begin for this tween. And then you can just use this in your, for instance, in my case, in circle progress indicator. The API for this widget is a bit strange. So for instance, if you want to provide a constant color, you have to provide this always stopped animation, which is very strange. But also this makes it so that you don't have to create animation for a color. You just need to provide a value as a value of your tween. And let me show you this in like the example. So again, if I tap here, this animation is a bit smoother than if it were like without implicitly animated widget. The source code will be shared with you after the presentation, so don't worry, you can then take a look here and see for yourself how it's done. But now let's stop actually at this and move to the next type of animations, which are explicit animations. So explicit animations are these like more powerful, more complex, and actually they require more of your attention, more of your consciousness in order to create them. And what happens is that you actually need to drive your animations in some way. Most commonly, you would use animation controller. However, you can use also some other ways to drive your animation. And when you use these animations, or when you drive these animations, you can use some very handy widgets like scale transition, size transition, fade transition, animated widget. They all accept animation and allow you to use this driving force that you've created with your animation controller to make some changes. So let's go back to our sample application. And here are actually a bunch of explicit animations that I prepared for this presentation. And here we have, for instance, some avatar with some glowing background. We have Flutter logo that is being animated. We have Slack logo that is being animated, some loading dots indicator, and some pulsating or pulsing icon here. So a bunch of different animations. All of them are like some kind of micro interactions or some kind of, let's say, decorators, right? They are not like game animations where you have some kind of engine model or whatever. they are all like if you were to use them, they would always be somewhere on the side of your app. Yeah, they wouldn't be some main element of your layout. But of course, you can also use explicit animations for that. But for the simplicity of these presentations, and also that because of I had these animations on hand, I'm gonna show you some examples of them. So maybe let's take a look at this very simple animation that we have here, which is this glowing icon. And I'm not sure if it's this. Yeah. So in case of very simple animations like this glowing icon here, there is not much that you actually need to do. Of course, many people would say that this is pretty cumbersome and there is a lot of boilerplate with animations. But frankly, all that you need to do is this, like maybe 10, 20 lines. Of course, you can maybe create some snippet for that, which I recommend to have a snippet so that you don't actually write this manually. But the point is that you always need to have animation controller. You have to create this animation controller. You have to use ticker provider state mixin or single ticker provider state mixin in order to provide a ticker into your animation. And you have to provide some basic properties for the animation controller. And you always need to remember about disposing this animation controller as soon as the widget is being disposed. However, the animation itself is very simple. Like there is not much to do. But I find it very interesting that, for instance, in this case, it's like not so trivial how you actually implement this kind of glowing animation, because when you think about this kind of behavior, it means that like something is being extended and then shrunk and extended and then shrunk. But many people tend to think about it from the inside of the widget. But for instance, in my case here, what I've done is that I'm shrinking padding. So I'm not making the container bigger or smaller, but I'm actually changing the size of a padding around the container, which means that actually I'm just like making the margins or paddings around the widget smaller or bigger. So, and this makes Flutter to like extend or compress the widget that is inside of that. Yeah, and my widget inside is just this decorated box. And I'm using animated builder. We're going to talk about animated builder in a second. But the most important part is that here, this like trick that I often share with people, and the same happens also here in this more complex animation, where I have like a bunch of this overlaid circles. And what happens here is that I'm also changing the padding around them so that this appears to be glowing. Another interesting approach to explicit animations is actually to not use the animation controller, but something different, which is a timer. So let me show you this actually in this example. So this dot indicator that you can see here on the right side. Here we have 5 dots, and what is like very how to say it? What is very distinct about them is that I couldn't find an easy way with animation controller to actually like animate this kind of change that you have like a bigger and smaller circles going across the screen. So what I came up with here was to actually use timer. And timer that has some period, and on each of these ticks, or on every period of this timer, what I'm doing is that I'm just switching the index of the currently active or big circle. Yeah. So period 1, this, maybe let's actually make this period a bit bigger. And how to restart my app. So when I made this a bit longer, you can easily see right now that on each tick of this timer, or on each period of this timer, the next index is being selected. So this is 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. And there is also some logic. Yeah, I need to always get a modulo of the elements. I need to remember about disposing the timer. And then I just have my dots. So each of this widget is a dot, which accepts its size, like default size. Yeah, so there is some kind of default size, and also which index is currently selected. Sorry, here, currently selected, and which index has the given dot. And here I combine something that we've learned before, so implicit animations, and my current approach, which is explicit animation. Yeah, so I explicitly say which widget needs to be bigger right now, and I just go through them one by one. And what I do, I just use animated container. So actually, I don't have to now animate the size of the widget itself. I just use animated container, and I'm using this fraction that is being calculated here, and there is also some logic behind it because I want to decrease the size of the next and the previous circle, right? So as you can see, the middle one is being the largest, and the next and the previous are being a bit smaller. But this is like only a detail. The point is that I'm combining both of these tools here in order to create pretty pleasant animation, right? So this is not something that you maybe wouldn't like to see in your app. Yeah, it's actually that something that is not obtrusive, is pretty nice to look at. And if you want to see some details about the rest of the animations, I encourage you to check out the source code later. So let's recap the animation controller. This is for the backup slide here. Animation controller. We need to initialize this in init state, and then we need to provide it to animated builder. And animated builder is a very handy widget, and you've seen that I've used this at least once right now. And animated builder is a widget that helps you to actually use your animation controller in the most efficient way. So what animated builder does is that it accepts a listenable. So listenable can be anything. It can be change notifier. It can be any other listenable. But in practice, you will almost always use animation controller, and animation controller tells animated builder when it needs to rebuild. And when it needs to rebuild, it will just run its builder function and will keep the child intact. So as you can see on the slide, there is a builder parameter and there is a child parameter. And the child is being built only once when the animated builder is created. So for instance, in my case of this previous animation, the icon and the decorated box wouldn't be rebuilt. The only thing that is being rebuilt is this shape decoration that we have here. So always when you use your animation controller, don't add listeners to animation controllers. This is what I've seen a lot, that people add listeners to animation controller and set state, but just use animated builder. The next topic that we're going to tackle today are twins. And actually, when you Google for twins, there's like different strange things showing up. And even on Wikipedia, there's like a bunch of different articles about it. So I'm gonna quickly introduce you to the twins and how can you use them in your Flutter apps. So twins are like classes that have very handy properties or functions that allow you to interpolate values or map them between the initial value and end value for a given progress of animation controller. So you can imagine animation controller as some kind of clock that goes from 0 to 1, or you can also specify different ending value, but by default it goes from 0 to 1. But in reality, not many animations go from 0 to 1. Usually they go from, like in my case on this slide, from offset 1 to offset 2, or they can go from color red to color blue. they can go from radius 21 to radius 97 or whatever. So usually it's not so simple that animations go from 0 to 1. They usually have some different values, and also usually they don't go from one value to the other value linearly on linear basis. Yeah, they follow some different curve, we say. So they have some different acceleration and deceleration than like simple 0, 1, 2, 3, 4. They usually have some kind of physics simulation or some kind of behavior applied to them. So for instance, when you open your screen, you have some kind of fast animation at the beginning and slow animation at the end, or something similar. And twins allow you to actually map from this animation controller value to some more usable representation of that. And you can use twins in two ways. So you can think about it in like some kind of a different perspective or relationship. So either you can create a twin from the animation controller. So on the left side, you can see that I just have some kind of animation controller, and on the animation controller, I just supply a twin to the method drive. But you can also have a twin somewhere in your app and animate the twin based off of the controller. So both of these ways are correct, and I always had problems which one to use. And finally, I just concluded that this is more obvious to me, but you can also use this, these are equivalent, and you can use both of them. And I also mentioned about these curves that you can use with your twins. And in order to actually convert a simple linear twin to some twin with a curve or based on curve, you actually need to use something called curved animation. And I also had some problems with that in the past, and I remember that I struggled to understand how it works. But in essence, it just means that if you have some kind of linear curve from 0 to 1, and you can see actually on the top from 1 to 0, you can see that this is straight line. And if I convert this with a curved animation, in this case, I think this was ease in or decelerate, it just makes this curve and actually the movement of this element a bit different. The same happens if the curve is a bit more, let's say, original. Let me show you this on an example in the real app. So I also have a sample. And for instance, here we have 4 of different curves and twins. And as you can see, the blue one goes linearly. The red one goes with a curve called decelerate. And this is similar to, for instance, iOS elements on UI have. Yeah. So for instance, when you open something on iOS, it's often using the decelerate curve. Then you have elastic in, elastic out. This is maybe useful if you have some kind of a bouncing ball or something like this, and you want to have some kind of elastic behavior. And also the bouncing out also shows some kind of reminiscence of some kind of physical object, right? The orange box goes to the right and bounces off of the wall, and this looks more or less of some kind of physical object. So as you can see, you can use twins for that. And let me actually show you how I've done this simple thing. So these are twin, not this. Here, twins. Yes, so what I do here, I just create a twin. This is very basic twin. So this is the first one on the top, which is linear, right? And I can also create a curved twin. So what I do, I just apply curved animation. So instead of using actually controller, I provide a controller as a parent to this curved animation. Yeah, later we'll see some more complex usages of that, but at this moment, let's just stick to this. And then when I have this get curved twin, I just, in my animated builder, and again, I'm using my animation controller as an animation that is supplied to animated builder. And then I just get the position for a given curve here. This is not optimized code, so bear in mind that actually I'm creating this tween on each build of this animated builder, and like this is not the perfect approach. But what I found is that, especially during the development, so this is another, let's say, tip and trick, especially during the development, it's not worth to create a tween as a, like, let's say, static property on your class, because it doesn't change, because this would be some kind of performance optimization. But actually what is very helpful, especially if you just want to tweak your animation, see how it looks like, is to create this inline with your animation or with your widget, because this gives you this like fast development cycle so that you can quickly iterate on the animation, and then when you're like ready, you can extract this and make this like a static field on your class, so that the tween is not being recreated every time you ask for that. Yeah, because here, as you can see, this tween is being recreated on each call to this function and so on. So it's a bit inefficient in terms of object creation, right? Or memory consumption. So again, tweens are very useful, and there's also some handy widget that can help you to use tweens even without animation controllers. So as you've seen in a few seconds ago, I had to create animation controller, and from this animation controller, I had to create my tween. And frankly, this gets a bit complicated with time, especially if you just have some kind of small thing to do, and you don't want to like make the widget stateful, and maybe you use some kind of different approach like provider or hooks, or some different approach that prevents you from easy usage of stateful widgets. So what you can do in such cases is use the tween animation builder. And tween animation builder is like this helper widget that allows you to animate value from some beginning to some end. And then also what is very interesting, it allows you to animate from this ending value to any other value that you provide as an ending value. And I'm going to show you in a moment what I mean. The nice thing about tweens is that tween can be anything. It can be number, it can be offset, it can be string, it can be your class, provided that you provided linear interpolation method. And it can be a color, it can be a text, it can be whatever you like. And there is also this point that tweens can be mutated, because when you create a tween, you can change its properties. So you can change its end or its start to any other value, and this will cause the animation to actually go to this value that you've just set. So in this case, you will see this in a real example. So let me actually switch to this page. So here is my tween animation builder, and this tween animation builder is actually very simple. So here is the widget, right? Tween animation demo. What I have here is just my child, which is a text, nothing fancy. And then I have my tween animation builder. I have some basic duration, which is necessary. I have my tween, which is just tween of double, but you can use any other type here. But the point is that I have some begin value 0, 0. I have my end value 1, 0. I can also provide my final value scale wherever I want. It can be 10, 20, 15, or whatever. And then in my builder method of my tween animation builder, I just use transform.scale, and this makes this widget to like appear from 0 to 1, yeah, and now it's over after 2 seconds. But then if I select this, change this scale to 10, this will animate or interpolate this value on its own. So I don't have to actually do anything else than just, let me show you, set state scale equal to 10, and this will trigger rebuild. This rebuild will trigger rebuild of this, and this in result will trigger rebuild. Oh, that's hard word. Will trigger rebuild of this builder and animate this value from the previous value, which was 1, right? It wasn't 0, it was 1. So and that now my initial value is 10, and I can animate this to 30. and I can animate this to 10. So if you have some kind of changing widget in your app that needs to like respond to some changes, and what is nice, again, this can be anything. This can be like a text. So if you need to animate some text from one value to the other, provided that you provided the linear interpolation function for that, then you can easily animate between values without any like some kind of additional animation controller or whatsoever. Pretty useful. I use it a lot. And I think I always start my animation with Tween Animation Builder. And if it's not enough, I switch to Animation Controller. Okay, we're like half hour in. And now we're going to move into some more advanced concepts. So this more advanced concept will be three. So staggered animations, spring simulation, and material animations. So let's get going. Staggered animations is like this holy grail of animations in Flutter. And also this is pretty complex when you go into like official tutorial where you have like a, I don't know, 10 steps in order to make a simple animation. But I want to show you how to actually make this staggered animation simple without additional packages, because there are some great packages that allow you to make the staggered animations easier and simpler. But here we're going to focus only on some vanilla Flutter implementation without any additional features, but of course you can use some of them. And if you have some multiple animation steps, yeah, like in this case, these elements appear one by one, and you want to actually use a single animation controller for that, then staggered animation is what you need. So let me again show you this in this real application, because it looks a bit better than on a slide. So what happens here is very simple. Here the header appears, and then one by one, each of the rows of this application go from the bottom to the top. And here we have some kind of a grid layout that allows to do so. Right? Nothing fancy, but of course you can make it a bit more complex, like all of them can rotate or can change their colors or opacity or whatever. But for the simplicity's sake, I just added this like slight transition. So let me actually show you some very handy things about this animation. So the trick that I often use in such cases where I have a staggered animation is to actually create my own animated builder. Why my own animated builder? Because this allows me to have some kind of a domain-specific builder and provide some values in a bit more readable way than if I would have to keep them in state or somewhere else. So what I do usually is I like delegate this the work to my specific animation builder. So for instance, I call this homepage animated builder, yeah, because this is going to build my homepage and animate this, and after that it's done. And what I have here is my custom transition builder. So here is this type definition, and this is a function that accepts contexts widget, which is very similar to typical animation builder. But I also have my homepage enter animation class, and this is like this super secret that I wanted to share with you. And what I do, I just delegate to this builder, right? So builder is this function, right? And I just pass the context child and home instance of homepage enter animation class, and I provide animation to that. And let me show you how it works. So my homepage enter animation is nothing else than just a class, nothing else. Like not a widget, not a change notifier, not anything, just a class that helps me to keep in one place all the information that I need about widgets that are being animated in some kind of domain-specific way, right? So for instance, what I know is that I have some header opacity changing. I have some row offsets, row second offset and row third offset, right? So these are my properties that I need to have on my view in order to animate this. And I also need my controller to keep track of the current progress. And when I create this class, I just create some twins. Again, this is not super efficient, right? Because I will create these twins on each rebuild. But these are relatively lightweight objects, and like it doesn't cost a lot to just create them. So I just need to create for each of the animations that I want to have that happen one after the other, or like they are a bit overlaid. So for each of the steps, I create this twin. Yeah. So header opacity, row offset, row offset, row offset. Right. So all of like the first one is my twin of double, and then the rest are twin of offset. They all start with 0, or here it starts with 0.5, which is like below the screen. Yeah, 0.5. And for instance, opacity ends at 1, and offset ends at zeros. Then I'm using this syntax that I've shown you before about twins. I'm using .animate, and I provide my controller, but I also wrap this controller in a curved animation. Yeah. Then, so each of them is wrapped with curved animation. However, the curve that I provide is not just a simple curve like before, is in, is out, or whatever. It's actually a different curve. It's interval. So interval is a curve that just takes a part of a given, let's say, animation controller progress, right? So this will make this curve is in for the 0 and 0.2 points of progress of animation controller. So animation controller will go from 0, 0.1, 0.2, 0.3, 0.4, 0.5, right? And between 0 and 0.2, this twin will animate this value, 0 and 1, with a is in curve, right? So only for this part 0 and 0.2, this curve will be interpolated with this function and between these values. And the same will happen with offset. Yeah, so from 0.15 to 0.30 with curve is out. And let me actually show this in reality. So this was animated with linear opacity. All of the other will just like decelerate with ease in, right? Really nicely. And this is how it like really, this has this really nice behavior, so that it makes this animation a bit smoother, right? And all of them happen in some kind of succession. And this succession is a result of these intervals being a bit overlapped on top of each other, right? So this first one happens from 0.1 to 0.25. However, the second one happens from 0.15 to 0.30. Yeah, so they are a bit overlapped, and this makes this succession like this kind of in steps, right? I hope this is clear for you, but if you have any questions, like feel free to post them in a comments section, right? So this is like this trick that I've learned is very handy. Like if I have to use staggered animation, so for instance, if you have like a login screen where a bunch of elements appear, or when you have some kind of bottom navigation that appears, a bottom sheet that needs to show some kind of elements, then this kind of behavior is really nice. And what is nice also about this is that whenever I enter this page, yeah, this is being repeated. And also I made this animation controller to repeat so that you can observe this animation constantly, but you could of course stop it at any point. And then if you want to use this animation, you don't need to actually create any stateful widget for this. Of course, you had to create a stateful widget at the beginning, right? So you had to provide this animation somewhere, right? This animation controller. But all in all, you operate only on stateless widgets, which is much more simple. And then you have your home page animated builder, and it has its builder, right? And you could also, of course, use child if you want. And then you have this very domain-specific object animation, and you can access like header opacity, row 1 offset, row 2 offset, throw free offset. So you don't have to like think a lot. What property do I need to use? You don't have clutter in your code. You can extract this file to some other, this class to some other file and test it just like in isolation. So if you have some kind of a specification from your designer, yeah, so that for the second 00, this screen needs to look like this, and for the second 05, this screen needs to look like this. So you can test this according to your design specification without actually running the application, right? Because you have some kind of description of what you want to animate. And this meaningful names is something that I really like crave for, right? This is something that makes the animations much easier. And also, if you want to add some other property, you don't have to modify the state. You just modify your, sorry, I forgot my keyboard shortcuts. You don't have to modify your state. You just add some other property to this class. You can change this. And because we are actually recreating this on each build, you don't have to hot restart your application. If you changed something here, it's being immediately visible in your application. Of course, you could make it a bit more efficient, and I suppose Krzysztof Sroka would like find some great way to optimize this. But in this case, where we have like a one-time only animation, I don't see a point in some premature optimizations. Okay, this was a lot about the staggered animations, but I hope that this like 12 minutes that we devoted to this will help you to actually start doing them, because I really think that this is something that makes your animations, makes your Flutter apps look a bit better, right? So when you open any like big application or some famous application, they always have some kind of staggered animations that happen in succession, in steps, and so on. If you take a look at some of the greatest examples like Reflectly, they all have this. And the next thing that I wanted to share with you is Spring Simulation. And Spring Simulation is something that I actually discovered recently, because before that, I actually was writing my own equations in order to make some kind of physics animations, especially with gravity. But it appears that there is this, no, Robert, this presentation is not with Flutter, but actually this application is being done with Flutter. And so I have a separate application. I'm going to post it later, but I didn't have time to finish. But this is something that I like find very amusing, that you have this kind of built-in classes in Flutter. So Spring Simulation is one of them. There is also a gravity simulation, and they all are in physics.dart library. This is built-in library in Flutter. And what it allows you is to have actually some Hooke's law simulation. So if you studied some engineering, you may, or have had some physics before, you may remember Hooke's law. And Hooke's law estimates or interpolates the spring behavior. And in Flutter, you actually have this. So for instance, if you want to animate something according to how it would behave as a spring, and many things in reality behave as a spring. So not only springs, but also some balloons, balls, some kind of devices, they sometimes behave like springs. And if you want to simulate some kind of a button or some appearance or some UI element moving around like a spring, maybe you have some vibrating element that needs to shake in response to some validation error, right? So you don't have to actually like calculate the curves with which the element needs to vibrate. You can actually make a physical simulation inside of your application, and that will make this button to vibrate more naturally than you would ever came up with any sort of curve. So here you can see a very simple case. So what I do here is that actually I just move this element from position 0 to 600 with some initial velocity 10. And then I'm using my animation controller to animate this simulation. So this simulation requires some kind of timer, ticker, that will move progress the animation from 0 to end. and the end can be like indefinite. Yeah, if you would provide some strange values to the spring could vibrate indefinitely. But the point is that you have to, in such case, make the upper bound of your animation controller much bigger than it used to be before, right? By default, it's 1, so it will animate from 0 to 1, or like tick from 0 to 1. But you have to actually make it a bit bigger. So in this case, because the sizes and so on are much bigger, I made 1500 seconds, or 1500, maybe not seconds, but units. And let me show you this in reality. So I also make this like spring here, and you can, let me show you again the source code. This is very simple. Like, you can just make some button and make the button like wobble around in your application very easily. And again, my initial position is 0, my end position is 600, and my initial velocity, so if I would make this, let's say 20, it would move a bit faster, and it would like go a bit further. If I would make this different, then the spring would go some different way. The important part is also the spring description. So for instance, if I would make this spring a bit heavier, need to go back and forth because I did it. So now the spring is much heavier, right? So it doesn't wobble at all. Yeah, so it just goes to one. But actually, maybe this is something that you would like to have in your application, right? So you just don't want to make this like wobbly, but you want to make this spring a bit stiffer. But you can also make the stiffness smaller, and this will cause, again, some different behavior. Maybe let's make the velocity bigger. And this is the beauty of Flutter, where you actually can just change some properties. I think this mass is being like 10 times bigger, and this changes this. Well, again, very strange behavior. Let me go back to something that looked nice. Yeah, but you see the point. You can have fun with this spring, and also there is much more. Like, if you go to the spring simulation, there is much more things here. Spring simulation. Then you have scroll spring simulation. What else? This is spring. If you go physics, gravity simulation, friction simulation, and clamp simulation. Yeah, so a bunch of very useful stuff. Maybe if you want to make some simple game, this can be useful. Okay, and the final thing that I wanted to show you is something that you probably are aware of, which is material animations. And material animations is a library made by Flutter team and material design team, I think. So I think by material design team, but for Flutter. So this gives you a bunch of very useful transitions and animations that are compliant with the material specification. So if you are making some apps with material library, then this can be very useful. So for instance, if you have some kind of screen and you want to navigate between the elements of the screen, for instance, here you have some kind of container transform, the same here or here. It doesn't look so well on desktop, but it would look much better on the mobile phone, right? So this kind of behavior is not default in Flutter, so you actually need to use this library in order to do so. But like, this is very easy to implement. There is a bunch of built-in widgets, and I often use, especially in my hobby applications or side projects, because customers usually have some kind of own behavior that they want to have. But in my side projects, I often use this kind of transition because it makes the behavior, the UX much more pleasant to look at. And maybe let's talk a bit about the elephant in the room, which is iOS junk issue. So many of you probably heard about iOS junk issue that makes the first animation when Flutter application starts on iOS a bit junky, a bit stuck. And I was trying to find some solutions back like 6-7 months ago when it first appeared. But since then, there's no good way to do it. There was some ideas to use OpenGL or something like this, instead of Metal, because this happens because Flutter had to transition to Metal on iOS, and on Metal there is no built-in shader caching, and this causes the Flutter, or actually the Flutter engine, to compile a bunch of shaders every time the animation appears, and there may be many shaders for even some simple animations like here. This is from I think one of the issues, so where you have like a rotating element, but there is like a lot of things happening actually. So the text is being rotated, the element is being rotated, some icon is being rotated, and so on. Some colors are changing, and this causes the shaders to the required shaders for that is a lot. So there is a project that you can follow with number 188 on Flutter repo, so that you can track the progress on some solutions to that. We hoped that there will be some solutions right now at the beginning of 2021, but still there is no like a viable solution to this, and I'm a bit worried that this can I'm not sure if it applies to Swift. I think that iOS engineers had some kind of like inside how to say it. They were able to provide some precompiled shaders, or they have some tricks in their sleeves in order to make these animations much smoother with Swift. Yeah, so this applies right now, from what I know, from all of the applications cross-platform, only to Flutter, which is a very sad thing to say, but actually this is, for instance, in my case, in one of our apps, we had to actually disable the animations on iOS just because they looked so bad, and like we couldn't figure out how to optimize them because so many things were happening at once, and until now we couldn't bring them back. Okay, we spent almost 1 hour on the presentation, and there's like a lot of things that I would like to talk to you about, like some packages that I know and some tricks that I know about animations, but like we don't have enough time, and also my throat is actually dry right now. And if you want to learn more, there is a bunch of tutorials that I want to share with you, especially the recent video by Filip Hraczek about developer designer and how to actually think about some UX things, UX aspects, animation aspects, some micro interactions, and so on when you create your apps. And I hope that this showcase of different techniques to animate helped you to, or made you inspired to try some of them. One special note is to the one of the libraries that were created, which is called Fanvas by creative creator, maybe not. This is his handle. So if you want to check out some really great tool to make animations in Flutter, I recommend to check Fanvas. So this is one of the samples there. And if you want to make some time-dependent animations, I highly recommend this animation library. Thanks a lot. Let me take a look at the questions, and if you have some, I will happily answer them.
Hi, Dominik. Thank you very much for your talk.
Hi, Rafał.
So I hope we have probably not much time for questions, but let's just see if we have any. Okay, so Katarzyna Białas, which type of Flutter animations is the most performance expensive?
Hi, Katarzyna. Yeah, this is a really tricky question, and even so there is like no clear distinction which animations are expensive and which are not. So but often folks can like shoot themselves in the foot when they make some animations. So for instance, I often mention that I recreate some twins in my animations, and I don't find this kind of behavior like performance expensive, but there can be some other ways that you can make your animation very or not performant enough. So for instance, when you are using some kind of elements that require a lot of computational power, like a backdrop widget. Yeah, so for instance, backdrop widget is using some primitive OpenGL techniques or whatever, how to call it. I'm not like a graphics engineer to describe this, but for instance, backdrop filter widget will definitely be expensive in terms of animation. So for instance, I also had this in my app where I had to like animate the blur. Yeah, so some text had to be blurred with some animation, and I remember this was very expensive, and like even on some high-end phones, it would take several runs for this to perform really well. And also, if you can, in your animated builder, try to extract as much as possible outside of your builder to your child, so that it's not being rebuilt every time that new tick of animation runs.
Okay, generally speaking, we are quite off the time right now, so we have to invite on the stage Krzysztof. So Dominik, once more, thank you very much for your very nice talk.
I thought that I have time till 7. I'm not sure why.
I don't know why. I don't know why. There was a clear agenda there.
Cool.
Yeah, but no worries.
Good luck. Thanks a lot. Thanks a lot for everything. Good luck, Krzysztof, with your presentation. Sorry for making you wait.
No, it's fine. It's fine. We actually used this time quite effectively, so no problem. Thank you very much, and see you later. Bye. Okay, so right now, just welcome on the stage Krzysztof Sroka, who will talk about debugging Flutter applications. Hi, Krzysztof.
Hi, Rafał. How are you? Hi.
I see that you have like what nice merchandise on you. Like, when can I buy this shirt?
Well, you cannot buy this shirt, but if you join Widgetis, you might get one.
Tell me more about that.
I'll tell you more about that later. I just don't want to waste anybody's time and just talk about Flutter rather than getting t-shirts. Although if somebody's interested, I'll talk about getting one at the end of my presentation.
True. Okay.
So how much do I have? 2 hours now?
No, you have like all the time on Word that you need. But before that, great. I would like to ask you a question. What is your what was your feeling after Flutter Engage and introduction of Flutter 2.0? How thrilled you are?
Not very. So I would say if you actually followed Flutter development in the past few months, you wouldn't be surprised about the advancements in tech. Right, the biggest advancements, the non-noble by default being in a stable channel, and web progressing also to a stable channel. These were really expected, so I wouldn't say I was very thrilled. I was happy that they come, because now we will be able to write some much safer code and less bug-prone code. What excited me the most is actually the investment of ads, of improving the ads experience on Flutter with AdMob. And potentially this can open huge doors to people who were interested in using Flutter in terms of powering their small businesses, of having free apps that were powered by ads. This is going to be much easier now. With the recent developments. I know it's still in what they said open beta, so changes are expected. But I'm really glad this has actually happened, and that was the thing I was most thrilled about.
Great for your answer. Just one thing before your talk, I would like to say that after Krzysztof's talk, we will have a quiz on Kahoot. So please just join us after this. Krzysztof, you're also invited. This quiz will be, there will be like 6 questions about the talks from today. There are some nice prizes that might be quite interesting for you as well. So yeah, that's it. And Krzysztof, the stage is yours. Let's start with the quick intro, and yeah, see you on the other side.
Yeah, so I'll start with just talking. My name is Krzysztof Sroka, and I'm I'm a Flutter developer, I guess, still. I have started, I've converted this, let's say, hobby into some really nice business. So I started a development agency called Widgeters, and this is our office. We are small group based in Wrocław, Poland. And I'm also a Flutter Google developer expert, co-organizer of Flutter Europe 1 year ago already. And yeah, in general, a nice guy, I hope. I want to start sharing a screen. And yeah, let me just open the proper screen. Oh no, my screen disappeared. And I'll move StreamYard to here. All right. So yeah, my presentation will be in Flutter. It's not a very thrilling presentation, but I found out making presentations in PowerPoint or Google Slides is much less thrilling, and the results are pretty much the same. So here we go. As I said, my name is Krzysztof Sroka, and this is about when Flutter goes red, what to do when the problems happen, right? It's not going to be only about Flutter when it's going red, the red screen of what I call a whoopsie daisy. So we actually talk about 3 kinds of problems. These problems, the problems 0, 1, 0, 2, are actually quite common. So I guess it will be most interesting to any kind of people. Problem 3 is problem with performance, which fortunately in Flutter doesn't happen all that often. But if that happens, I'll tell you what you can use to actually debug this. So first, I'll actually show what we are going to toy with during our talk. So first thing is a really simple screen that can basically grow. And as you can see, we already find ourselves in a pickle with not that great UI. Something's wrong. We overflowed by 58 pixels. I can't even press next button anymore, even though I should. All right. So I should have applied never scrollable physics or never scrollable. Physics or never scrollable animation here to this, yes. So that's the first kind of problems. The problems with layout. What happens if we find that what we expect doesn't really work as expected? And this is quite a common issue, since we use things like columns and rows and list views and grid views all throughout our Flutter apps. This is one of the basic components, and these errors happen very frequently when we don't know how to use these basic components. So the second thing is going to be a simple math game, and I hope it's not going to crash anymore. The math game is a very simple presentation for very young kids who like to learn more about maths. It's not really a game; it's a game of luck. So, as you can see, there are several operations. There are several numbers, and some combinations of these numbers might be wrong. And I try on the other screen now to make it go. Let's see. Oh yeah, I need to hot 3 dots. I'll toy a little bit with this. Oh, and this is a problem that we actually want to fix. So we got this infamous red screen. And this red screen also happens quite often, and when it happens, it's mostly because we did something wrong, like the division by 0, which wasn't that smart from my side, right? And now, the next thing we're going to talk about, and some people might recognize this, is this simple game called Game of Life. If you don't recognize it, I added some nice features to actually show the shadow or shade of the past lives. This Game of Life is a very simple game on Cellular Automata with some rules. that makes that basically is played on a grid. It's not really a game. It's more of a automata that we can advance and see what happens next. And in this particular case, I've added a very simple combination of black blocks here that actually reproduce themselves after several steps. So you can see how it glides through my screen and will glide forever as long as I play advance. But naturally, this doesn't show any kind of problem. So the problem here is that I can steer the size of the board, the size of the cell, and let's say I'll do something differently, and I need to reload this page. I need to hot restart. Yay. And what happens when I give myself a bit too much space? This is our matrix of 100 rows and 100 columns, is that suddenly things start getting slower. It's not that slow, but maybe I'll just shrink it a little bit more. 250 by 250. Need to restart it. Whoa, and now you can see I'm trying to even navigate to the page, trying to press a button. So this is unfortunate. Like, of course, we would like to have Flutter as a very performant thing, but sometimes it just isn't. Maybe because we would like to have too much of memory occupied or something else, and we'll see how to maybe debug these problems. That, as I said, don't occur very often. They just happen once in a while. And that's about techniques you can use to debug these problems. So I'll list it here several things. I'll call them first, read before you shoot. 2, step-by-step debugging. 3, beyond the basics, the Flutter DevTools. 4, 1 visual cues worth 1,000 logs. And 5, what takes that long? And as you can see, there is a last item over debug prints, which I thought I might just talk about, but I think it's not going to have time. And it's also more the let me show you documentation rather than anything fun. But if I find some time at the end, I'll actually talk about some debug prints and what they can do for you. So read before you shoot. I'll now convert my tiny screen to show you also what I do have in my IDE. So that is my brilliant IDE next to the presentation. Dominik, I do have an Macros app. However, some debugging of performance doesn't really work well. I don't know why. Of course, these applications that I've shown you are here to demonstrate problems. In real life, you wouldn't like to have such a big game of life board probably displayed all the time. Or you wouldn't divide by 0, or you might, after like your second or third try with a column, learn how to deal with these problems with the overflowing widgets. But let us first go and start with the simplest solution to our problems. So you can frequently see both in Stack Overflow, in some chats, or in some Facebook forums that people ask for help. And what do they show you when they ask for help is that I have this code, and they'll paste the code or actually make a photo of the code and then paste it. And I have this application that overflows, right? And I don't know what to do. And then you ask yourself, why do I need to do this? I want to help that person, but that person doesn't give me one thing I want the most, that is text logs. If you ignore what happens on the console, you are shooting yourself in the foot. And yeah, maybe you have bad experience with another languages like C++, where the errors on the console are really unreadable, and only after some time, some months spent on a very trivial errors, you recognize some patterns of messages being thrown out, and you can basically say, oh, it might be that I didn't terminate a string. Oh, there might be illegal access. In Flutter, one thing that I like the most is the developer experience, and that includes also the debug logs. So if you run Flutter both from console or from your IDE, you can see in various places in various IDEs, but in VS Code that I use, a debug console, which will print out all the logs from the application, or rather all the logs from a device that relate to Flutter. And here you can see we actually got something, and we can read through it. I know it's a lot. We can open something that I'll open up later. But these messages are very carefully crafted to actually pinpoint what the problem is and show you the possible solutions. So if you ever ask for help, please do first check if the logs on the debug consoles or wherever you actually have them contains anything like that. Exception codes by rendering library. And in both these and the red screen types of failures, we will see that these errors usually get printed out on the console, and you might be able to actually see what happens there. One nice thing is that works in VS Code, and I think it also would work in IntelliJ-based IDEs, is that you can actually see a link here. So VS Code makes me want to navigate to this link, which in VS Code it doesn't cooperate well. I'll just show you what it does. It goes to the same exact widget that is responsible for this problem. In this case, we can actually pinpoint, oh, this is a column, and this column causes this. It's not a container. It's probably not as low as this elevated button that gets hidden, and it's not as an icon, separate icon card, but it's a column rendering that fails here. The second thing that you can notice is that some text is more grayed out because it's less important, and possibly could be on a bit lower. But the text in brighter white or in brighter gray actually tells you some solutions to what you're experiencing. So it says, consider applying a flex factor, for example, using expanded widget to force the children of our render flex to fit within. Okay, this is complicated. And as I said, Flutter is quite good at it, but sometimes do imagine that this is written by people at Google. So for them, working with Flutter for several years, this is obvious. What does render flex mean? And what's a natural size? Everything is in natural size. And what's a flex factor exactly? But let's just apply this solution using an expanded widget to that column. All right, so let's see if it happens. No. There's another problem. Expanded widget has a wrong ancestor. Expanded widgets are placed directly inside flex widgets. And actually, I read the documentation, so I know, it's within the columns, because column and rows are flex widgets. So I'll just go back and go and say, well, what we can do here, right? We can maybe expand the icon card, the spacer, the elevated button, but it's probably this growing list that makes us go back. So what we could do is wrap this into some kind of an expanded container, like, let's say another, let me write this quickly, expanded child and a column, right? Column with children, and I don't know, take this, right format, and oh, we have it in different place. Let me just, is that, okay. What happens here? We can still add this. Maybe it's something wrong. Now I have this one. Let's see what's going on. It still is expanded. Oh, and why does it happen in the middle of the screen? I'll show you later how to actually debug this case, but I know how to apply a correct solution here. So what do we actually need? I want this to be, for example, scrollable. We want everything of this to be, for example, scrollable. So how about if I apply some different scrollable widget? Yes, these are scrolls. Why is that expanded here? And I'll leave it at this state, because then we'll go into layout issues to discover, and later part we'll discover why is this here. What did we do that now instead of showing a full list, we only see half of it? No. So that's the first part, basically applying what Flutter tells you to. Now let's play a math game. Math game is much more fun, because we will go to the calculator class and see, well, this is actually number 1, this is some operator for, and yes, I have some symbols equals. Let me just find where I put the operator. Play a math game button does something here. And here, as you can see, I would normally just grab a random operator, which would make me fail once every 40 times if I'm lucky. But let's say I just always want a division. And eventually, I'll reach a point where 1 in 10 times, of course, when a wrong division is going to happen. For the time being, we can relax. Learn some maths. Like, why is it 0? Oh, it's an integer division, so if it rounds everything down. Oh, yes, that's it. So now we got another problem. Obviously, I could show you again, there is some kind of error-causing widget, which was calculator pinch, thank you. And as I told you, this is not going to pinpoint really the problem. The problem is somewhere much, much deeper, right? So, but this problem happened during the build time, and because it did happen during build time, the whole widget actually looks like that. And we cannot really pinpoint what happened, right? There's an exception, something bad. And we could say, okay, this calculator stayed built and so on, but I'm not gonna do this. What I'm going to do is show you a second technique, and it's more advanced, it's much more common in older languages, I would say, which is a technique of debugging. So in VS Code, we can break anytime we want, actually. And we can do this also on exceptions. And in this case, I'll show you what happens when we break and when this bad condition happens. We can also set a breakpoint manually, which will make us actually stop when we try to execute a part of the widget. But that would make us stop every time something happens, right? So every time, for example, we generate a new number, and we don't want to do this. We just want this failure to get caught before we get to see the red screen. Some more. Smart. Maybe next time I'll just do 1, 2, 3 Yes, great. Now, this is much more interesting thing. I'm not sure how well it is going to look like. Because now we found where the exception actually occurs. And this view lets us actually investigate step by step what happened here. So as you can see, we don't have any red screen yet. This is going to happen when we let this exception continue and get thrown. But we see we caught exactly the moment when the exception happens. In of course, integer division by 0 exception, in the operator, that's the operator on integer of integral division. So it's going to cut off basically something, truncate the remainder from the integer if it didn't true. So, and you can see in many IDEs, you would see this very same combination of controls. And these controls are continue. So basically try to continue the execution of a program until possibly next exception, until next breakpoint. Step over, which will try to forward to the next instruction. Step into next instruction on the same level without going deeper into the execution, into the stack. Step into will actually go deeper into the stack of execution, and step out will try to move up, so to the caller of this function, of this operator. And let's go. So well, this is some kind of integers class. On the left-hand side, we can see also variables. Oh, this is going to help. So this integer is 8, and the other is 0. So basically 8 divided by 0 is integer division by 0 exception. And we can add some more variables. I'm not going to show them. I actually, it's hard time. I had a hard time to make them work, but you know, that's why I'm not going to show them. But usually they can be an expressions that you can evaluate every time you stop. But what I have here as well is a call stack. A call stack contains all the known calls throughout all the functions that happened that are on a stack that caused this exception. And if I go upwards, so step out, I can actually see, well, it got a bit shrunk. So it got to perform rebuild phase. And this is a place where we actually catch the exception. And we can even investigate if we were here to discuss how the internals of Flutter work, we could actually go over here, but I'll just go over what happens here, but I'll just show you how the controls work. So yeah, debug doing build equals false. And build. So this is actually, I'll tell you, this is a widget that we actually tried to build. It's going to be replaced by error widget. And if I step over, I'm moving to another step, another line of execution. I can step into and see, okay, the next thing it tries to execute is a error description building this. And if I can take a look at this is a stateful element. It doesn't really tell me a lot, right? So Flutter is quite a bit magical, but it finds, oh, this is a page that caused the problem, because we have a widget called calculator page. But as you can see, there's no calculator page here in a call stack. That's because when this error occurs, we are not actually inside of the widget. We try to perform rebuild during a set state. So this is a set state call somewhere. And yeah, you can see this is self element and inspect every single thing. It's 123 widgets deep. And I had a discussion some time ago about how deep the Flutter tree is. And if you think like, oh, I'm just going to, it's just a few widgets. It's a very simple application. There's a page view, and inside the page view there's this, and it's 123 widgets long. So material app page view, this, it's totally totally crazy. But this is something you need to be wary that, well, you can go really deep, really fast with Flutter. Now, okay, our description, what next? Let's step over, I don't want this. So you can see I didn't really move even in a line because we stepped over some expression in the same line. Now we step over, we don't go inside, we go to debug report exception, and it's going to actually print out everything that we want, but we don't want this. Yeah, it's still something happening. You can see something going on, but let's step out. We don't want to step in. Dirty false, it doesn't really matter. Perform rebuild, and some assertions that are true. And if we let it continue, so we could here put some more breakpoints, and I don't know if dirty count is now 1, dirty elements is no, this is not going to happen. Dirty element needs reporting, so this is probably not going to happen. But let's say we try to assert here, and we try to continue. Let's see where it stops. Down. Huh. Well, that's very good. And this is another assertion, so probably we don't need this. So let's say, can we reach this point? Well, we won't reach this point anymore. Okay, did I put something over here? Oh, yes, yeah, and you can see also the breakpoints that we set manually over here. Now I will just let every exception continue. So this kind of view is actually quite neat. If something happens and you really want to inspect the data behind it, you can do this in your own. You can do this in your own widgets as well by setting a breakpoint, and then it's really easy to inspect what is the data that causes this problem. Now, when you see in this view the polls, actually it doesn't do anything, right? The application continues. This error is no more, it's just a widget, and we continue. So that's a second technique of debugging our application. This is a very lengthy topic, how to use these controls, the breakpoints, how the conditional breakpoints that you can set when some data is equal to something that you want. And inspecting calls like these watch variables, watch expressions and variables. This is a really deep topic, and I invite you to actually dive deep into it if you want to master the art of debugging. Debugging not only Dart code, but actually any code, since as I told you, most of the languages have the very same idea on debugging. Okay, so I'll just close this core patch that was opened and get here. All right. So we have this nice glider that glides through my page, and it's pretty performant. I can show you now a simple thing that we do with performance problem when we try to debug performance problems. And usually we won't do this in debug mode, but I'll explain to you why. And we'll just show the performance overlay. I need to save. Yay. Which we will start. This performance overlay doesn't really show much, but you cannot read what's here, these labels, because it's on the wrong kind of background. But what you can see is actually the performance of Flutter during the both UI phase, that is a phase that is controlled by Flutter, and the raster phase, this is controlled by the Skia engine itself. And whenever you see a high bars like this, that means that something took a long time. We ideally would like everything to happen below the bottommost line that you see here. But if something shoots very high, well, this is a serious problem. Now, I told you we're not going, as you can see, there's a label called debug here. We are not going to do in real life debugging this performance issue on an application in debug mode. You would need to actually run application in either release or profile mode to see how it performs. In a debug mode, Dart has lots of checks, additional checks that it strips away in release mode that are executed, are here just for development purposes. All the assets and all the heavyweight stuff is there. So if it happens to you that you have a performance problem, then first thing that you do is actually run it in profile mode or run it in release mode and see if a problem exists. If a problem doesn't exist in release mode, that means that something heavyweight done in debug mode, maybe some calculations that are hidden by assertions that are stripped out by Flutter. But normally, if it doesn't happen in release mode, it's not a problem. Right? It might be a problem for you as a developer because the app is slow to work with, but then there are easy things to do when you just try to avoid the problem with some widget being slow in debug mode, like removing it. Now, of course, this is a very small board. And I'll just go to the file here, Game of Life, and I'll say, well, 250 is my favorite. This is going to require a read since we initialize. We initialize the state here with these values. And as you can see, well, this is, trust me, there is our glider in the very corner, and it's going to glide through eventually. As you can see, both the threads and both the threads on the Dart side and the threads on the Skia side, they'll take a lot of time to execute. Now, what we could do is use, this is going to be a little bit out of order, but it's since we are here in the code, what we could do is just check what's actually the speed of execution here of something that happens when we press. So we do advance, right? An advance button, if we find it, on state, it executes board, next board. And the next board calculates for all the rows and all the columns. It calculates the next value of a cell. So you might suspect, well, if a board is too big, maybe it takes that much time. And we here can introduce something called timeline. Timeline is a tool from Dart developer package, which is also included in Flutter SDK. And timeline allows us to measure time of execution of both asynchronous and synchronous functions. So we have, okay. So what we do with timeline is that we actually, if we have a synchronous function, that is a function that doesn't do any asynchronous operation, as we can see here, well, this doesn't do asynchronous operation, doesn't do anything with the futures. Next cell is a function that returns a Boolean, it's also synchronous. We use a start sync methods. And yeah, we need to actually wrap it. each timeline will now record. I need to actually add more operations. This timeline should actually report to us what was the operation here done. Let's see how long the operation took when we executed. The app is quite slow. Maybe it was, yes, I didn't even save it, so it's not even reloaded. Hot reload complete after 16 seconds. Try to advance. Okay. We see two dots happening. I can't even scroll. So this is so heavy, my system is actually stopped working. I don't see oh no. I think something got wrong when we tried to do too much. So I'll get back to it in the end when we have some more time to debug this, but timeline is also useful when we try to start asynchronous functions. So timeline has timeline. Timeline can also be used to measure the asynchronous function calls. I actually should have prepared this better, but yeah. And asynchronous calls, of course, don't take a lot of time themselves. Like these are not the calls that would cause this kind of behavior. The performance of the app really sluggishly redrawing the small glider, and only the small glider is just a few pixels that happen over here. But the timeline can also be useful when we measure, for example, calls to the backend, HTTP calls that we don't know how long they take, and we just want to measure how long the Flutter actually takes from the execution of a call to the end of the call. Okay, I'll just make the game of light a little bit smaller and reload the app so that it doesn't clog my computer that much. Okay, and if you see actually, the timeline gets overlapped, and this performance overlay gets overwritten with the cycle of execution, and now the these big spikes happen really rarely. They actually will happen more often if I click a bit faster on the advance button, but yeah, in regular work, they don't even seem to be noticed. Okay, right. So I'm gonna also show you the two things. I'm gonna show you now the most advanced thing that Flutter developer can do. So actually go into the .devtools. So .devtools or Flutter DevTools, because it's been renamed, but I don't know really what's the official name right now, is a set of tools that contains lots of tabs. And actually I'm going to open them in a web browser, because while we can open them in the IDE, in VS Code, it's really very, it needs some work and it's a love from developers. Okay, yeah, I'm closing the old one. I'm launching the DevTools in the browser again. Yay. And DevTools is a lot of things. First of all, it's Flutter Inspector, and there was a talk about on this from Majid Hajian on Flutter Engage in the community track, and I urge you to watch it a little bit because he talks more about the Flutter DevTools. But Flutter DevTools gives us several nice things that we would struggle to actually do in ordinary life or in ordinary execution of a program. So first of all, let's get back to this example. Well, I'm going to just dismiss the performance overlay as well, because it's hard-coded here. And I am going to actually inspect what's happening here. Like, what's the problem with this UI? Flutter DevTools have this really nice select widget mode, which I can just point some widgets to on some widget and see its layout. So I can see, well, this is actually the icon, yes, nicely. It's embedded into something, and we see this these very thin borders around several widgets. So these basically denote where the widgets start and end. And we can actually go and see, well, this is the layout of these nice widgets. So it's 300 dp wide, it's 56 dp high. And if we go up, see this card. So they're nice cards, and they are somewhere lower and lower and lower and lower. So they should be displayed. Let's see in a list view what happens here. Well, the list view, as we can see, is only half the size. So, oh no. So something's taking up this size. And we can either continue with select widget mode, or we can just try to, go through these widgets here. Now, my time is almost up. So I'm gonna go and very quickly explain to you a few very nice features. So here we can, oh no. Yeah, this happens sometimes. And I need to go back into this. So what we can see is this spacer that we've added takes lots of space, right? And this spacer is actually something we had in a code to just make sure that this button is on the very bottom. Unfortunately, this doesn't really work nicely. So we could either remove this spacer or we could do some other things. I'm not going to go into the solution here. One other thing we could use, the main is latest post. Ah, yes. Let me just go through. And but I'm gonna show you a couple of things that we can do with Flutter DevTools, which are visual things. So first of all, we can show debug paint. Debug paint actually shows us much more information about the layout of every widget, and it's very useful if we consider something badly aligned, badly adjusted. It's not very easy because the selection of colors by default is a little bit hard to see. It's not very, doesn't have a huge contrast, but there are several lines going through the screen. The green lines mean that there is some kind of a row happening here in a direction on right, and this is a column or some scrollable container in direction and lower direction. Oh, this arrow here actually is the page view. As you can see, when I move the pages, it stays the same, unlike the other thing. And the blue things are the padding, There are some other things that you can see, and this is really easy. This is easy tool to show all the layouts and constraints and sizing on a screen without needing to dive deeper into what is where. If we see, oh, there's this kind of widget, or there's, for example, widget that has a huge frame around it, we can go and pinpoint the problems much easier. Let's also show paint baselines, which is not going to be very visible because we just have one button and the baseline is barely visible, but it's something that you might want to take a look at when you go deal with text. And one fun thing I would like to show you is the Repaint Rainbow. So Repaint Rainbow is very similar to what we've seen before. It's actually going to draw some kind of colorful frames around widgets that change, so widgets that need to repaint. And we can see what happens when we try to. It's not going to show very well because the outer layer overlaps with the lower layer. But when we press the button here, the button's border changes on various colors, but also the bottom line here. And this actually means that the whole container gets repainted, even though nothing changes here. So there's some problem of too many repaints happening. You can see, for example, here, there's something being repainted in several places. So if we have also performance problems with, for example, huge stacks of things being repainted, we can use a repaint rainbow, which is going to show us very nicely now, which parts of the application get rebuilt every time we do something. And if you go into your application, enable this and see like everything's just changing colors magically, this probably means, and without of course any interaction from a user or any movement on the screen, this means that you have a problem and you repaint your UI way too often. In practical terms, what we could see over here, maybe let's just go over here. You could see that every time I press a button, the color here changes, and this actually indicates that the whole container is changing, even though these icons don't change themselves. The icons are getting painted just on demand. So if we see this kind of problem, I will just show you a simple technique on how to fix it before I finish. There is something that's very nice tool called Repaint Boundary. And we can use Repaint Boundary. So the default algorithm for repainting things is that the Flutter, when it repaints a smaller widget, it tries to go up, up, up until it finds a repaint boundary. And when it finds a repaint boundary, then it tries to distribute repaint from that repaint boundary down. Until, of course, it meets either the end of the widget tree or another repaint boundary. So if we wrap something within repaint boundary, we create like a separate space of these widgets to repaint. Of course, there are other elevated button and text are complex widgets. This is not just two of them. And if we do this, you can notice that now suddenly when I press this button, of course, additional elements get added as usual. This line no longer changes, so this color no longer changes. So we avoid repainting the whole application here. Okay, I'm out of time. I'll just show. I'll just move this away. And oh yeah, let me disable the rainbow, which is going to be it's not going to show. Oh, Let me rotate this thing again.